In this video, I'm going to talk about the rules for determining significant figures. And the reason significant figures or sig figs are so important is because in chemistry, we're not just looking at numbers, we're looking at measurements. And we have to know how precise those actual measurements are. What we're going to do first is go through the rules of significant figures. In another video, we'll actually look at the calculations of how we deal with these values and these measurements when we're doing calculations. So the first rule that we look at is any digit that is not 0 is significant. So this is pretty straightforward. We have the value 1.234 kilograms. Because all four of those digits are not 0, we have four significant figures or sig figs in our value. So the rest of the rules we're going to look at actually are all about the zeros. Where they are determines whether or not they are significant. So let's look at an example here with zeros between non-zero digits. So here we have the number 606 meters. Notice these are all measurements, so we do have units associated with them. And I know that the 6 at the beginning and the 6 at the end are both significant because they're not 0, but this 0 in the middle is also significant. So we have 3 sig figs in 606 meters. Now we look at zeros to the left of the first non-zero digit. So here we have 0.08. We know that 8 is going to be significant because it's not a 0. And these two zeros are simply placeholder zeros. They're just making sure the 8 is in the right spot. And so they're not significant. They're not actually part of the measurement. They're just making sure the value of the number is correct. So 0.08 only has one sig fig. If a number is greater than 1, then all zeros to the right of the decimal point are significant. So here we have 2.0 milligram. We have a number greater than 1. 2 is definitely significant because it's not 0, but this 0 is also significant. And what we're looking at here is the fact that when I make this measurement, we always estimate that that last digit is an estimated value between two markings. So I want to make sure I have as many digits as possible. And so if I'm able to measure 2.0, even if that last digit is estimated, that's still a much more precise measurement than just having 2 milligrams. So this adds a level of precision that we were able to determine based on our measuring device. So we count both of those digits as significant. Now we're going to look at numbers less than 1. So we have a couple of different positions we have to worry about here for zeros. The first that we look at are these zeros to the left of this first non-zero digit. Now we looked at these before and we said that these were insignificant, so they're not significant figures because they are merely placeholder zeros. They're making sure all the other digits are in the right place. And then we have a 4 and a 2, which we know are significant because they're not 0. And then we have this 0 at the end. So just like we saw up here with the 2.0, if we have zeros after the significant digit, and those numbers are all after the decimal place, then what we find is that last 0 is significant. So this value has 3 significant digits, which is the 4, the 2, and this last 0. Now let's go through some examples to put these rules into action. So the first one we're going to look at here is 4.9120 grams. Again, notice we have units because these are measurements. And what I'm looking at here is I've got 4, 9, 1, and 2 are all non-zero digits, so we know they're significant. But here we have a 0 at the end of our value, and we said, well, if it's important enough to put that 0 at the end, it is going to be significant. So this number has 5 sig figs. So you can either abbreviate this sig fig as a short or use SF as an abbreviation. Now we go on to our next value. These first zeros here are all just placeholder zeros. They're making sure all the other digits are in the correct place, so those are not going to be significant. Then we have 3, 4, and 1. We know those are significant because they're not 0. And now we have this 0 at the end, and it's also going to be significant. And so in this number we have 4 sig figs. Now we go on to 209. We know that the 2 and the 9 are significant because they're not zeros. The 0 is also significant because it's between two significant figures. So in this value we have 3 sig figs. We look at 21.00. We have 2 and 1, which are significant, and we have these two zeros after the decimal place, and because they're after the decimal place, they are also significant. So we have 4 sig figs. Now we're going to look at one that's a little bit different here. We have 390, and when we see how many sig figs that are there, by different arguments, we could say this is 2 sig figs, or it's 3 sig figs. So the question becomes is whether or not we count this particular zero. And this actually gets into a scenario that gives us an ambiguous number of sig figs. And in chemistry, we don't like things that are ambiguous. We like to know things. So there's a couple of different things we can do. The easiest solution is, if we want to say, yes, this has 3 significant figures, is we can actually rewrite the number as 390 with a decimal point. Now it looks kind of odd to have a decimal place with nothing after it, but when we do that, it lets us know that yes, all 3 of these digits are significant. So this value would have 3 sig figs. Another alternative is to write it in scientific notation, and when we do that, we can choose whether or not we want to have 3 sig figs, because now we have a 0 after the decimal point at the end of a number, so it's significant, or we can choose to omit that 0 if we only really want to have 2 sig figs. So in this one we have 3 sig figs. Here we only have 2 sig figs. So depending on how we write this number will determine the number of significant figures. So if we have something that looks like this 390, we want to rewrite it to make it very clear what the value is and how many significant numbers it contains.